This program simulates wave physics on a 2D grid to create a real-time ripple effect. Of course, this is a very simplified abstraction of real-world wave mechanics, optimized for visual effect and performance rather than physical accuracy. The oscillation occurs because the wave equation is fundamentally a second derivative formula. The term average multiplied by 2 minus current act as a restoring force. If a cell's value is higher than the average of its neighbors, this term becomes negative, pulling it down. If it's lower, the term becomes positive, pushing it up. This continuous overcorrection around the equilibrium point, combined with the energy transfer between the current and previous state arrays, is what generates the persistent oscillating motion of the wave. The computational load of the calculation for every cell, each frame, creates a direct constraint. Smaller cell sizes increase the grid resolution and visual smoothness, but demand exponentially more processing power, establishing a practical limit for real-time animation in the browser environment. Now let's examine the complete implementation to see how the HTML structure, CSS styling, and JavaScript logic work together to create this visualization. The HTML structure consists of the header element containing input controls and a figure element, acting as a container for the canvas. The CSS establishes the foundational layout, with rules for margin reset, box sizing, and flexbox positioning. The styling for the figure element uses display grid and place items center to center the canvas element within its container along both the horizontal and vertical axis. This CSS grid method provides a direct way to center content without calculating offsets. The visual presentation is minimal, as the primary function of the interface is to host the canvas element, which is managed entirely by the JavaScript logic. The initialize function prepares the simulation environment. It calculates the number of rows and columns the grid will have based on the container size and the chosen cell size. It then sets the canvas element's pixel dimensions to match this grid. The function also obtains the canvas position on the page for accurate mouse interaction and creates the two primary 2D arrays, car grid and priv grid, initializing all their values to 0 to represent a flat, undisturbed water surface. A helper function, create2D array, is defined inside it to generate these arrays. The grid iterator function is a utility that executes a provided callback function for every cell in the grid. It uses two nested loops to iterate through each row and each column. For every cell coordinate, it invokes the callback function and passes the current row and column indices as arguments. This function eliminates repetitive loop code and centralizes the process of traversing the entire grid. The render grid function is responsible for drawing the current state of the simulation to the canvas. It first clears the entire canvas, then uses the grid iterator to loop through every cell, setting the fill color based on the cell's value in the car grid array. Higher values result in a lighter blue color. For each cell, it draws a square at the corresponding position. If the show grid setting is enabled, it additionally draws a series of horizontal and vertical lines to visualize the grid structure. The update grid function contains the core algorithm that calculates the next state of the wave simulation. It starts by swapping the references of the car grid and priv grid arrays. It then iterates over each cell in the grid. For every inner cell, it calculates the sum of its 4 immediate neighbors from the priv array, finds the average, and applies the Wave equation. This computation creates the propagating wave effects and applies energy loss. The animate function is the main loop that drives the simulation. It uses the request animation frame method for smooth timing. It calculates the time elapsed since the last frame and accumulates it. When the accumulated time exceeds the defined cycle time, it triggers the update grid function to compute a new simulation state and reset the accumulator. Regardless of an update, it calls render grid on every frame to draw the current state, ensuring visual fluidity. The mouse handler function processes mouse movement events over the canvas. It converts the mouse pixels coordinates into grid coordinates. It checks if these coordinates are within the inner grid boundaries to prevent interaction with the edges. If valid, it sets the value of the corresponding cell in the car grid array to the impulse strength, creating a wave disturbance at the mouse location. The input handler function manages all user input from the control panel in the header. It reads the values from the cell size, show grid, and cycle time inputs and updates the sysconfiguration object. If the input changes requires a grid reset, such as altering the cell size, the function cancels the current animation, calls initialize to rebuild the grid with the new parameters, and restart the animation loop. The complete, heavily commented source code is available for download via the link in the description. I will now scroll through the entire implementation. That's all from my side. Be well.